WarsawJS.
So, hello everyone. I would like to talk about functional programming in TypeScript using FPCS library. So, let's start from the introduction. So, a few words about me. I have been programming for over 8 years already. Mainly, I'm using Scala, TypeScript, C++, and Rust. So I graduated from University of Warsaw in computer science, and I have been working at Evolution for the last 1.5 years, and as a Scala backend developer. So I don't use TypeScript at work, but still I can share my experience with FPCS library in TypeScript. So let's talk about FPCS library. So this library is created by Giulio Canti, and it's actually highly inspired by Haskell, PureScript, and Scala, and includes the most of popular data types, type classes, and abstractions, and has own implementation of higher-kinded types, which TypeScript doesn't support natively. And the only one downside what I noticed, it's not really so beginning friendly from the documentation perspective. So you need to know some functional programming basics to use this library. So why should you learn FPCS? So to get better type safety first of all, and to model your code in an elegant way, and also get all profit from FPCS ecosystem, which includes such libraries as IOTS for validating JSON in runtime. If you know ZOD, so it's actually similar library, but it's built on top of FPCS. And to use, for example, Monaco TS, which is just a port from Scala Monaco library, and it provides possibility to manipulate um, immutable data structures. And just to become a better programmer, to know more paradigms and to learn about some new techniques and maybe use in your code. And you shouldn't know any math except basic ones, such as lambda calculus or category theory, just to start using this library. And a few words about the presentation. The FPCS library is not widely used at Evolution, so we have just a few projects which are isolated, and we have FPCS as dependency, but it's not like our main stack. And the presentation is more about my personal impressions and my personal findings, and it might be a little bit uh, subjectivity opinion, but still. And I don't want to bore you with buzzwords and hard understanding definitions, so we will naturally learn using some basic examples. So let's start. Uh, let's define a basic model. So we define a user with a username, which is string, and we have a function create user, which accepts username and returns a user. So yeah, let's create a user. Does anyone see some problems with this code? Everything looks fine. So let's jump into create user function, and here we just call user of method, and still everything looks fine, isn't it? Let's jump into of method, and surprise, here we have some exceptions. And actually, I marked constructor as a private to disable inheritance, and actually created a static method of just to have, let's name it smart constructor. And we check here username length, and we throw an exception, and we are checking for content of this username just to allow only numbers and Latin letters. And in case of success, we return the new user. So yeah, we need to use strike hedge. And the problem here is that we don't know actually what errors can we have here. This type of error by default is unknown. And we can define some errors actually. So let's define username length is a valid error. So we also mark it constructor as a private, and we have some smart constructor. And also we created a tag field just to have possibility to check by tag instead of using instance of, which is basically unsafe in JavaScript runtime. And let's define the second error, that's basically the same. And we define user validation error, which basically is union type. With username length is valid error, and username has special characters error. So we change it actually errors what we throw. And what does it change? We still have the same create user. We can use instance of just to do something with errors, handle them in some way. So the problem is here that we still can have some new errors, and we don't know if actually set of errors has been changed. So we still have error unknown, and here is the problem. We use exceptions, which is basically go-to programming. So we can check create a user function and everything looks fine, and we need to go deeper. Of course, we can read some documentation or some comments, but we don't have a possibility to check all exceptions what we can have in JavaScript, TypeScript. So what can we do with this code? So just to know which errors can we have, and also to have a better type safety. So the simplest thing what we can do is a return user validation error. So here we have a union user validation error or user. And instead of throw exceptions, errors, we will just return them. So the signature of create user has changed, and we still need to return user validation error or user, and the code itself has not been changed. And actually our app example is a little bit different. So we can check using instance of, or we can also check with type property, and after that we can work with a user, or we can handle typed errors. We know exactly what errors can we have, and we still can have some exceptional situations. So basically exceptions are for exceptional situations. We don't need to catch out of memory error or something like this. We need to catch our business logic errors, and that's it. And can we do it better? Yes, we can. Let's introduce some type named like either. So it's either left or right, and left has a left value and right has a right value. And we also have the same pattern to have discriminated unions, just to check what error, what part of either we have. The signature has changed. Instead of returning a union, we return something like either some validation error or user. So in the smart constructor, we just create left value or right value. So it's pretty similar to the previous one. So here the signature also has changed. And in our app example, we call create user. We have user or error, and we can use is right helper function from FPTS library, and we still can take all benefits from using this. So let's extend our model. Let's add a new field, which is named like is blocked boolean. By default, it's false. And let's add a helper method, which basically copies the existing username, because we have an invariant that username should be validated. So if we created a user, that should be totally fine if we will create a copy of user with the same username. And actually, is blocked can be true or false, and these states are both valid. So and create so actually create user is the same, and create a new function which has signature like it takes a user and returns either some error or user. But just like error in type signature is not really helpful. Error can be anything. So we would like to define our business logic error, just like user is already blocked error, and it's basically the same as before. And we would like to return either user is already blocked error or user. And block user function is pretty straightforward. We are checking if user is already blocked. If it's blocked, we return left value with error. In case of everything okay, we return right value with modified user. And here we just need to check if we had error with creating user, and after that we would like to block user, and we need to check also if we had error, and actually it still feels imperative, and I personally don't like this code. It's hard to understand what's going on, but we use pure functions. We handle all our business logic errors gracefully. We have typed errors, and yeah, we would like to improve this code. But before that, we need to get familiar with some new. So let's go ahead. Let's assume we have some function named multiply 10, which takes a number and returns number and multiplies this number by 10. We have add to function, which just makes +2. And we have show function, which takes number and returns strings. So it's basically toString function. And let's combine them together. And what result will we have here? Anyone? Yeah, 42. So let's make it generic. So let's define add function, which takes two parameters instead of one. So we take two numbers and we just return a sum of this. And it's getting worse because it's actually hard to read and define which function we call here, and we can have more and more argument passed. So we would like to improve this, and we can improve this using pipe function. So we just use an initial value at the beginning. We read it from left to right. So we have 4 at the beginning. We multiply 4 by 10, and we add 2 at the end, and we just convert this to string. And what if we would like to use our, let's say, generic add function? We cannot use it just like that because we need to pass a function which takes only one parameter. So we need to inline some function which takes only one parameter, and we need to use our let's say generic add function. And it's actually not the right way how we usually do that. Instead of that, we just convert this function to caret one. So we take one parameter and we return a new function which takes also one parameter and returns a number. So using this approach, we can just like bind add2 and we have a new function returned here. And it's basically better to read, in my opinion. Let's jump into, let's say, pure JavaScript, TypeScript world, and we define some array, and we use well-known methods like filter, map, flat map. And here, what result will we have? Anyone? Both type and value. And that's it? Only 2 values in array? Oh, yeah. Yeah. That's for you. Yeah, here we just filter our array, so we are removing zeros. We map our array over some function which multiplies by 4, so we have 4 and 4, and we have flat map which returns a new array. So, and actually you should remember flat map. We will use it a lot soon. So if we just like, let's say, if we would have here map instead of flat map, we would have nested array, right? I really love this syntax, but we have some problems here. What if we would like to add a new functionality for the array implementation? I had in my life many times where I would like to write a generic function which will do something with array or some other data structures, but we cannot. What actually can we do here? Just like to fill it natively, we can extend array prototype, so and add a new method here and use. But please don't extend array prototype. What else can we have? We can just add a pure function and call it if it needed. So it sounds much better to me. So let's think about some exercise and let's create some dummy problem. Like, let's say we need to continue this chain and get the sum of the first n elements. So, for example, we would like to get a sum for the first three elements. And the implemented solution should be optimized for potentially frequent queries. And it's pretty simple. So we need to create a new array with partial sums, and we can simply look up by index in a constant type. So the problem here, that we need to create a partial sum array. How can we do this? We can use something like scanLeft. It's basically similar to reduce, but it remembers intermediate values. It's one of my favorite functions. So here we have zero value, we have a reduce function, and as the last parameter, we take an array, and we do this in a separate function. We will check later why we did this. And actually, the implementation of this is not really essential, so we can just assume that we do some reduce and remember each value. So if we will have a reduce function, so which basically sums accumulated value and the current value, so we can get an array of partial sums. The implementation of this is not important, and it's your home task, let's say. And let's define a lookup function, which takes some index and also takes an array also as a new function. And it returns an option at the end. Option we define in the similar way, just like either, but the left side doesn't have a value. So just like the left side doesn't exist. And let's define a lookup implementation, because it's pretty simple. We just use a normal JavaScript syntax, and we have from nullable function, which actually takes some value or undefined or null and converts it to option. Because even by the default, if we use our bracket syntax to get a value, we always have with actually value type. We even don't have value or undefined in TypeScript. So we would like to use option, but option is not essential. I would like to focus on either today. So yeah, let's go ahead. And we can use it in this way. So we had our initial chain, and we just pass the result to scanLeft to get our partial functions or partial sums, and at the end we call lookup for the third element. And also what result will we have here? So we create 10. Yeah, that's true. We have sum of 10, but still it's valid. So okay, it works fine, but still it's hard to read and understand what's going on, because we need to read it from the middle, and execution is not clear here. And we would like to use scanLeft and lookup as a method call, but we cannot for now. And how can we achieve this? We can use pipe. So we use here predefined functions from FPTS, just like filter, map, chain, and we use our custom functions like scanLeft and lookup. And the result here will be the same, but it looks much better. And actually, I would like to show you a new proposal into ECMAScript, so which provides a pipeline operator. So it looks even better because we just like call a method on the initial array, and we can chain our functions this way. So we converted our an initial approach to something like this, and it looks much better because these calls feel like a method call. All execution functions are tree-shaked well, because if we create, let's say, custom implementation and a lot of methods, JavaScript bundles cannot tree-shake it and remove unused methods. So, but it works well with pure functions which are not related to some objects. And if something is not used, so this simply will not be included into your bundle. And FPCS already provides a lot of functions like scanLeft and lookup. These functions are also included to the FPCS library. So let's come back to our example. How can we actually change it? We would like to use our success path here. Just like if we had right value, we would like to use it again. If we had some error, we would like to handle this. And we can use simply using chain, which is flat map, as we saw looking at the array implementation. So we just create a user and we return here either, and we call chain on this either, and we return here in the function a new either. So at the end we still have user or error, and we can handle all intermediate errors, and all these errors will be typed. So what's the benefit here? So we converted our imperative-like code to be more functional and more elegant, and it's pretty cool. Let's go ahead. Programs without dealing with the outside world are really useful. We need to write to console, read from the database, insert some HTML elements into the DOM tree, and let's define a new function, insert user. So here we simulate some synchronous inserting into the database, but instead of this, we just call console log. And this function takes a user and returns a void. And let's use it. So here we just create a... yeah, I have a couple. Yeah. I was talking about dealing with the outside world, and we need to deal with some writing to databases and doing some other operation with the world. So, and usually these operatings are not pure. So let's take a look again into our insert user function, which basically does the simple console log. We simulate asynchronous inserting. It's not really useful because usually we insert into the database in a synchronous way, but we will change it later. So let's call our insert user. So first of all, we need to create our user model using smart constructor, and we have either some error or user. So we are checking using isLeft helper function. If we had some errors, if we had, we just return with either. In case we have the right value, we call insert user function and we return a user. And I would like to do something like this. We were not checking for the uniqueness here just at the beginning. So that's totally fine to insert two Alexes. And we would like to do something like this. And yeah, we have a duplicate code, basically. And let's talk about referential transparency. And all pure functions have the property of respecting evaluation substitution. What does it mean? Uh, that means that the following refactoring should be safe. So we can replace function calling. We can extract this into a separate variable, and we can just reuse it. And it works fine with the pure function. And the question is this refactoring safe in this example? Anyone?
No.
Why?
Should be.
Because objects immutable in your case, I think.
Yeah. Basically, here we have the same values here. So that's totally fine if we have two ithers. We just replace the values. But what about side effects? And at the beginning, we had two database insertions. So we did here an insert user in the middle of create user function. So if we call it twice, we insert into database twice, right? But if we replace with one create user calling, we just insert user only once, so we cannot replace it safely. So it's not actually safe, and functions with side effects violate this evaluation substitution property. So we don't have referential transparency, so we cannot refactor our code easily. So how can we achieve this? We can just make it lazy, right? So instead of having calling just create user and to get either immediately, we create a function which doesn't take any parameter and returns either user validation or user. And in this arrow function, we call create user. So we can safely replace these values with a function calling. But this code will not work. We need to call these functions to get values. So in this case, we will insert a user into database twice. So we can inline this function and call it immediately, or we can extract this into a separate variable and simply reuse this. And congratulations, we reinvented IO. So what does it mean? IO with A represent a non-deterministic synchronous computation, but can cause side effects and yields a value of type A and never fails. So let's change our insert user signature. So instead of void, we will return IO with void. So basically, by type signature, we warn about some side effects inside. So and of course we make it lazy, so we just return a new function which calls console log. And let's come back to our create user. Is everything still okay with this code?
No.
Why?
User return function.
Yeah, right. We need to call this because insert user returns an effect, and
1 minute.
it's too hard. Insert user returns an effect IO that must be run, otherwise it will be ignored. So we just call this. And is this type signature fair? No, it's not, because we still return either. We don't warn about any side effects, and we convert this type signature to inform users about some potential side effects. So instead of either, we return IO either, and that's basically we represent like IO either, which basically composes together IO and either. And we can replace actually with IO with either, with IO either. And yeah, here we will just use from either helper to convert pure either to IO either. And yeah, looks almost fine, it works, but it's not an idiomatic approach. We shouldn't execute effects directly this way. Rather, we need to compose effects using chain, aka flat map, and transform with flat maps. So let's refactor this. So here we just use pipe function. So we call insert user, and insert user returns IO. So we call map with IO, and we ignore arguments, and we just return a user. So we have IO with either. So it should work. So it's getting better, but it still feels like an imperative code. So we can just change it and use this approach, but it doesn't work, and we need to change actually type signature. So that's we use TypeScript,
And that doesn't
and
work.
this
Oh,
code finally compiles and works.
Is it fine to debug it?
thank you.
So yeah, we can debug it normally, and actually we can insert our, let's say, console logs inside of pipeline. So we can actually console log, it's synchronous operation, so it can be turned out like IO. So we can chain IO, and actually I have an example here. So let me take, yeah.
The
So
answer is
here,
yes.
so yeah, we can for example chain left side, and we can, for example, use console log just to print our errors inside of pipeline, or we can also use console log inside of on the right part. So that's totally fine.
A couple of options, yes?
Yeah.
Next question? He was next. Sorry, sir.
Thank you. Is there any sort of generic monad decomposition in FPTS? Like, can you define your own monads and have them be composable?
Yeah, sure. You can define your type classes because FPTS library provides higher-kinded types implementation, and you can extend your with all this ecosystem with your new type classes. So that's totally
course, sir.
doable.
All right. Can we please have a big applause for Aleksander Sorokin?